Okay, here we have this Python project which defines or contains two main service files in which it defines some web methods, some operation. This is going to run some web methods operation. So this is going to run by different threads because it's running in a web mode. This is going to start up a web server, and then it's going to calculate some information about the customers, has the order count, total revenue, and it's going to try to calculate the orders, right? So uh, this balance service, what it does is to keep the balance and calculate the customer balance for this operation. And then um, it has a couple of issues that is going to show up here in the during this test case. In this test case that is running concurrency, what it does is to it's to try to or simulate an order creation that is going to deduct and run some testing. For instance, here the order shows the balance of 72 orders, but the the correct value will be 100. This is the expected value, 100. So what I can see here is a couple of issues in both services, because the first bug that I detect was here about the current balance, because it could be the scenario and it's happening as we can see here in the test case, that the information is not in a consistent way because it's not running in an atomic process. Because if two requests are trying to hit the same operation at the same time for the same customer, then it reads the balance, but then there is another thread that at the same time is trying to modify this account, then it's going to leave this information in an inconsistent way. And it could be that the 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 customer is going to be overcharged, and this is going to cause us some issues. What I'm going to do here is to try to solve it by adding the, the threading here. And what I'm going to do is to add a log. First, what I'm going to do is to add the log import here. Threading. Balance log by defining the balance log and threading log here, and we're going to use this this new log in order to um, create an asynchronous process, and we're going to protect this all these lines by adding this condition. So all this is going to run it in this environment. this is going to protect all this code by adding this log, by running in a synchronous process. That is going to ensure the atomicity of this operation, and the information is going to be consistency. And here also in this process single order, uh, where I can see is it's happening the same by update the stats. So here, and by update daily stats, this is going to this is running also in race condition, because the balance doesn't have this protection, this synchronized thread protection. And if the same customer is trying to read the same balance, it's going to retrieve different information, and is going to it could be the case in which this process could be with insufficient funds, or the this value could be charged twice, uh, and this could be solved by adding a lock here, a synchronous process. This all this code must run in an asynchronous in a synchronization process, and we need to add this log uh, in the same way with and then I need to import here, import trading, and mm, this is the stats log trading. So all this code is going to run in a synchronized environment, which is going to prevent that only one thread is going to get access to this code. And with this is the issue here, and here is going to be solved. So let me run it again. It's expecting one balance, order service, order log here. It's expected these dots. So it passed. It passed because now this synchronization process is happening by adding this log, and all this code is going to process in an ACID operation, in which there is a single process that is going to protect only one single thread is going to process, and is going to call this code, and then the other threads must wait until the first thread is going to complete this process, and with that we can make sure that the information is going to be consistent.